Looking at electric circuits F number 6. All right, in order to solve this one, we're going to have to once again find where we have two of our three variables, right? Because once again we're using V equals IR. All right, so V equals IR is what we're going to use here. Our other formulas we're going to use, R equals V over I, and I equals V over R. So those are our three equations that we're going to have on this one. Now, what's the easiest thing to find on this one? Well, if you notice right here, you have both voltage and resistance. So if you have that, you can find current. You can find current going into that. So for the ammeter, I equals V over R, which is going to be 5.0 over 25 ohms. So we have 5 volts over 25 ohms, which is going to be 0.20. So in this meter, 0.20 amps. Now we have that current, we can look to see that we have both the top and bottom of the parallel circuit. We have both their currents. So what we're going to do here is add those together, because what goes into the parallel circuit must be what comes out of the parallel circuit. So in other words, 0.05 amps is coming this way, 0.2 amps is going this way. The resulting amperage is just adding those together. Our meter is down here in the bottom right. So what we have here is 0.05 amps plus 0.20 amps. And that gives me 0.25 amps for the entire circuit. Now, we can use this 0.20 amps in the bottom part of the circuit to actually figure out the voltage going through the 25 ohm resistor in the bottom part. So if we want to find the voltage on that bottom leg, first resistor, I use V equals IR, which is going to be 0.2 times 25 ohms. And for this one right here, what's 0.2 times 25? It's going to be 5 volts. So that one's 5 volts. All right, now what does that tell us about the top? Let's look at the top leg of the parallel. Well, the one thing you've got to make sure you know is that in a parallel circuit, the voltage across one leg of the parallel circuit is equal to the voltage across the other leg. In other words, we're talking the whole thing. So the voltage from this point up here to this point over here is going to be the same. All right, so the entire voltage across this top part is going to be equal to the voltage across the bottom leg of the parallel circuit. So on the bottom, we have a total of 10 volts, which is going to be 5 plus 5. On the top, we have 7.5 volts, which leaves us with, for this other voltmeter, 10 minus 7.5 is going to be 2.5 volts. Now the voltage across the entire top is 10. The voltage across the entire bottom is going to be 10. So we're almost there. We need the resistor in the top part of the parallel circuit. So we use R equals V over I, which is going to be 7.5 volts over 0.05 amps. When I do that one, I get 150 ohms. All right. Then I need the resistance of the one that's in series with the parallel combination at the very end of the circuit. So working on this one, I get R equals V over I, which is going to be 5.0 volts. And where do I get this current from? Well, the current going through this is the total current in the circuit. So I get 0.25 amps down here at the bottom. So 5 divided by 0.25 is going to give me 20 ohms up here. And the last thing I need to do is figure out the overall circuit voltage. To do that, all I have to do is add up the voltages used by any given electron in the circuit. Once again, think of it in terms of one electron. So pick any path. So if it comes out of the power supply and goes to the top path, it crosses 7.5, 2.5, And then finally the one in series, the 5 volts, and goes back around. So it crossed a total of 7.5 plus 2.5 is 10, plus 5 gives me 15 volts. Just to double check your answer, if it took the bottom path of the parallel circuit, it would go across 5 volts for the first resistor, 5 volts for the second resistor, total of 10 volts, plus 5 volts for the series at the end. And that completes it.